Welcome everybody to this weekly call on AI topics, hosted and sponsored by the ZIP community. This weekly series is called CSIG, and in the chat, I've put the link to where the recording will be posted. The slides are out there already. I'm going to hand over to our speaker today, Bill Murdock, who's going to introduce himself and speak about engineered AI still matters for question answering. Over to you, Bill.
Hi, thank you. I'm a researcher and a development manager for the IBM Watson Discovery product, and I'm going to be talking today about the question answering task and the use of engineered AI in answering questions. So the Stanford Question Answering Dataset, or SQUAD, is a really popular, very large data set for question answering. It's reading comprehension data, meaning it consists of passages, questions about the passages, and answers that are located in the passages. The passages are coming from Wikipedia. The creators of the data set at Stanford gave these passages to crowd workers who saw the passages. For each passage, they wrote some questions and then selected some text in the passage to be the answer to that question. So here's an example of a chunk of Wikipedia. This is part of a SQUAD passage. Here's a question that someone looked at this passage and wrote, and then the answer is a little chunk of this passage. So answering reading comprehension questions by itself is it's an interesting AI challenge, but it's not a particularly useful capability. Nobody has passages and they say, I want to be able to ask the system a question about this passage and get back an answer. People, if they have a passage, they know what's in it. They're very good at that. However, the idea of being able to pull a passage, an answer from a passage seems like an important subtask of factoid question answering, that a computer can potentially go through thousands or millions of passages for a particular question, find the one where it can pull out an answer, and then show that to the user. And now you have a really useful question answering capability. So there's sort of an idea here that you can combine a system built for SQUAD with some sort of passage search and get a useful question answering system. And so a hypothesis that comes out of that idea is that a system that excels at SQUAD will also excel at factoid question answering. So we're going to explore this hypothesis in this presentation using two different kinds of technologies and two different kinds of data sets. We're going to look at a highly engineered multi-strategy question answering system, and we're going to look at a statistical single strategy deep learning system. And we're going to look at those systems on both SQUAD and on a generic factoid question answering data set where the questions were not written for particular passages. And if the hypothesis holds, we'd expect to see similar trends between the two. But if we don't see similar trends between the two, that would be a challenge to this hypothesis. So the factoid data set that I'm going to be presenting results about is, we call it Factoid 1527. It's a fairly small set of questions. They're factoid questions, meaning the answers are typically entities or numbers. The questions are written without being tied to any particular piece of text, and we're using Wikipedia and Wiktionary as sources. Unfortunately, it's IBM confidential, so we can't share it with the community, but we're hoping to work with community accessible data sets in the future so we can do more comparisons with other state-of-the-art systems. So here's an example of a question and an answer that's a factoid question. It's not actually from this 1527 set because the 1527 set is confidential, but it's sort of in the style of that data set. So the multi-strategy factoid question answering system that uses knowledge that we're going to be using in our comparison is called GDQA, or Discovery Deep QA. It's a simpler version of IBM Watson 1.0 that's designed to be deployed as a cloud service. It has a lot of engineered features, knowledge bases, and rules, just like the original IBM Watson. Very expensive to create, very big and complicated, not as big and complicated, because the goal for the system is to be able to run on a cloud instance that has like a finite amount of processing power and is expected to handle many requests at the same time, as compared to IBM Watson 1.0, which was really designed to answer one question at a time, no multiple users. So this architecture is essentially the architecture that you see in Ferrucci 2012, the introduction to the Jeopardy Watson 1.0 system. Maybe a slightly different rendering of it, but the basic components are the same. You start with a question, you analyze the question using some combination of statistical models and rules. Once you've analyzed the question, you're going to go out and find passages through a text search. The passages will be sources of answers. The answers go into an answer scoring component along with the question analysis that's just going to apply rules and knowledge bases. The answer scoring is going to result in a bunch of features on each answer. Those features can then be used to rank answers via statistical models, and you're also going to merge the answers using knowledge bases that tell you that these two entities are really the same entity, they're just different surface forms. Once you have a merged and ranked list of answers, you then put that out as output to the user. So when we're applying this technology to Squad, there really is no need to do passage retrieval and over a text search index. Instead, you just take the Squad passage and you plug it right in where you would have found a passage from retrieval, and then the rest of the system just works out of the box as it is. Now we're going to compare this to this single strategy statistical approach. The single strategy statistical approach doesn't rely on manually engineered features, knowledge bases, or rules. It's just going to take text in and put ranked list of answers out. One statistical model doing everything. Not everything, because there's still some passage retrieval, but pretty much everything. And then in the Squad case, you don't even need passage retrieval because you're given the passage. So it really is the statistical model doing all the work. And then finally, we're going to compare an integrated approach where we take this single strategy statistical model, we use it as it is, just pull the passages and stick it into it. And then we treat the outputs of that as one more source of answers and one more source of features on the answers. The scores that the statistical model gives to each answer is a feature on the answer. Answers that did not come from the statistical model may get merged with ones that did, and if they don't, then they just don't have a value for this, what the statistical model says. Those all go into the final statistical model for answer merging and ranking that's going to then rank the answers and provide the ranked list of answers at the end. Again, you don't need any of this passage retrieval if you have Squad passages, so same issue there. So here's an example of a component in DDQA that hopefully provides some sense of the kinds of like logic and reasoning and knowledge that gets used in the DDQA system. We have many such components, but I'm just going to provide one illustrative example. So DBpedia is a knowledge base of structured information from Wikipedia. It has things like this entity is an instance of this category. It has things like entity has these slots with these fillers. Yago is a semi-automatically constructed taxonomy from WordNet and Wikipedia. So it'll tell you things like this category is a subcategory of this other category, that city is a kind of place or something like that. And then we have a bunch of Yago disjointness axioms. These are things that were built for the IBM Watson 1.0 system, so that internally built by IBM, and they specify disjoint types like person and location. A person cannot be a location. None of these axioms are like completely true all the time for all possible interpretations, but they tend to be close enough to be useful that if you have an answer that's a person and the question was asking where, it's probably not a very good answer most of the time. So here's an example of a question: what Kansas City has the highest population, where city is the type of answer being asked for. You would put something like this into Yago Tycor, where it would use its knowledge bases and its disjointness axioms. It would look at an answer like Wichita and say, yes, this does appear to be a city. It would look at Bob Dole and say, well, this is a person, and I know that that city is a location and that persons are not locations, and so therefore I know through my logic that Bob Dole is not a city. And then it looks at a bunch of random letters and says, I don't know what entity this is, so maybe it is a location, maybe it's not a location. I can't tell you for sure. So this is the kind of reasoning that goes on in this one of the many components in DDQA. So Yago Tycor is very expensive. I mean, DBpedia and Yago are free for us because they already exist, and WordNet and Wikipedia already existed, but they both took huge investments of effort. If you wanted to do something similar for copper mining or just pick a business domain that's of interest to you, it would cost an awful lot to do that. We created the disjointness axiom, so those were a little bit expensive, and all the logic to reason about the entities and the types and when you use what. This was a big investment, and this is just one of dozens of components. So in contrast, I'm going to show our statistical model, the single strategy deep neural network. We're using something called bidirectional attention flow. We didn't invent this. There's a citation at the bottom here. It's an off-the-shelf deep neural network. It clearly required some effort to build this thing. There's a whole bunch of structure, lots of different layers. You have to try a lot of different things to get a good system like this. But there are no manually engineered features here. There's no knowledge base that needed to be created. It's just, it gets trained on a bunch of inputs and outputs, and now it has a bunch of inputs and outputs, and it can map straight into answers. So while it's clearly not like a thing you could throw together in a weekend, it's a pretty small cost compared to the many components in DDQA. And so IBM would really like it to be the case that the statistics alone is the best. That if you just take the bidirectional attention flow on the previous slide, that's the best you can do at answering questions or something along that lines, because that would be the thing that would give us if that were true, it would be really good in terms of being able to provide great results to our clients at very low cost. So we're going to assess that hypothesis in the context of that goal. So the metrics we're going to use to do this measurement include exact match, which is just the percentage of questions where the top ranked answer exactly matches what the answer key says is right. Mean reciprocal rank, which is the same as exact match, except you also get partial credit for answers that are not top ranked if you get second ranked or third ranked, etc. And there's some other metrics in the paper that was linked to in the invitation of this presentation. And so here's the results we see on Squad. Now, if you take the statistical system, you get an exact match of 66% and a mean reciprocal rank of 71%. The combined integrated system, DDQA plus statistical, got 67% and 73%. So the statistical system alone is providing nearly all the power. Adding DDQA provides very little benefit despite all of its great costs. So on the basis of this data alone, I think any reasonable business would conclude that it's not worth the huge engineering cost of doing DDQA, and you really want a pure statistical system to do this kind of answering. But let's look at the Factoid 1527 results as well. On this data set, the statistical system alone is delivering only 15% exact match and 21% mean reciprocal rank, compared to 47 and 56 for the combined system that's going to get all the benefits of this complex statistical deep neural network, but also all the power of the rest of DDQA, all the Tycor and the answer merging and the ranking. So in this context, the statistical system alone is providing very little power, and then including DDQA is providing an enormous benefit. So at least on the basis of this data, we've failed to confirm the hypothesis. A system that excels at Squad will also excel at Factoid question answering system. We had one that excelled at Squad. It's not excelling at Factoid question answering. I think to really conclusively say one way or the other, we need more evidence, more bigger data sets, more empirical evaluation, more rigorous methodologies in some cases. That you can see a lot more details in the paper. So why do we have this contradiction? Is it that Squad is a toy problem? We're remember that it's not a particularly useful capability by itself. So the real question in my mind is a statistical system learning reading comprehension, or is it just learning statistical trends in how people write questions for a given passage? Now, I'm not talking about the metaphysical question here of can a statistical model really understand something. I'm really talking about a much more practical question. Are the systems learning to identify answers given a passage and a question, or are they learning to identify answers given a passage and a question written for that passage? Because if that's all you've learned how to do, it's not really a thing anybody wants done. Now, clearly the statistical system did something on Factoid 1527, but not nearly as much. So I think these questions are still open, but at least have a little bit of evidence in the direction of maybe there's cause for concern here. So here's an illustrative example from Squad. Oops, sorry. So you have a Squad question, what are dart frogs known to secrete? And then here's the corresponding Squad passage. Dart frogs secrete lipophilic alkaloid toxins, where the words used and the order in which they appear line up very nicely. The answer is right after that. It's the first noun phrase after the question. I think when somebody's writing a question, looking at a passage, you get a lot of this sort of stuff. Not always, but a lot of the time you get trends like this. Here's a different source that's not where the Squad question came from, that's also answering the question, but it's doing so in a much more complicated way. The word secrete appears in one sentence. The word frogs appears in the next sentence. It's all kind of muddled, and you have to sort of understand the whole thing to make sense of it. And I think this reflects much more the kinds of things you tend to see in the general factoid question answering system that you do see occasionally in Squad, but just far less often, and is less an important part of the statistics involved in being really successful on the data set as a whole. So I think this is a problem that's sort of ubiquitous in, ubiquitous is maybe too strong. It seems like a common problem in modern machine learning research. I think most people are familiar with the old joke about a person who dropped something. They're looking for it under the street light because the street light is easy place to look for it, but that's not really where it is. And I think Squad has a little bit of this characteristic to it too, that Squad is the way it is because it was easy to generate a huge amount of data and train statistical systems on the data, but it's not really the thing you want to do. It's not answering questions from people who don't know the answer because they want an answer. And it doesn't seem like it's as good a proxy for that task as you might imagine at first. So what about factoid question answering? Is that a toy problem too? Users generally don't actually want a system that only answers factoid questions. If you give someone a question answering system, they're going to ask all kinds of questions. And if you tell them, no, just a factoid, they don't know what that means. And it's not really what they wanted. Most information needs require more than just an entity or a quantity to address. But sometimes users do ask factoid questions. When they do, it is nice to be able to provide a correct factoid answer. The complete factoid question answering problem seems closer to a real world use case than Squad reading comprehension, at least to us. But this will only be proven when we show that it adds real value as part of a comprehensive information finding system. So, I mean, there are systems out there that do factoid question answering, Google and Wolfram Alpha, for example. But to our knowledge, nobody has a big commercial success doing narrow domain factoid question answering about customer supplied content, where a business can take its own possibly internal content, feed it into a computer system, and be able to get factoid answers out of it. This is a part of the ambitions of GDQA, and I think what it would take to become a product someday. But I don't believe that this is something that's been a big success yet in industry. So we believe that engineered AI still matters. There's mounting evidence from data like Squad that a single strategy, deep neural network, are the state of the art for answering questions, but we believe that this might be an artifact of the limitations of Squad and the limitations of similar data sets. There are other data sets out there that are big, that don't have the same flaws as Squad, but we think they might have other flaws. We need more experiments with more data to really understand the space here. But we still believe that there's a significant role for multi-strategy systems that make extensive use of engineered knowledge and rules. There are some kinds of tasks where you can do dramatically better and provide way more value with this kind of approach. So that's all I have. So I'm happy to take questions now. So let's start with questions in the chat.
So you've got quite a few.
Is there anything I should start with, you think?
I've unmuted Chitra. Do you want to ask your questions?
Okay.
Sure. Thanks, Susan. Hi, Bill. Very interesting talk. So
thank you.
In the solution architecture, you had statistical models in various places, one around QA parsing, the other one with the answer scoring, and so on. So what are these statistical models trained on to begin with?
So it depends. So in the question analysis space, typically the statistical models you're going to have here are going to be trained as much as possible on the particular question analysis tasks. So for example, we're using statistical models to identify the answer type in a factoid question, like what city. You'd say city was the answer type because it appears right after what. That's fairly easy for a statistical model to learn from even just a couple hundred manually labeled examples. And it generalizes fairly well across different data sets. And so you don't really need to redo it for each data set. The statistical models that we see at the end of the pipeline here for answer merging and ranking, these are typically trained on just question and correct answer pairs because their job is to identify which answers are correct and which answers are not correct. And so that's the signal that they need. Occasionally we use statistical models in other subcomponents, and I think in each case we'll look at what the inputs and outputs of that subcomponent are. If possible, we'll get training data specifically for that subtask, but sometimes we'll do things like we'll use whether the answer is right as a noisy ground truth for that subtask. If we have a component, for example, that's trying to decide, and we don't have one in GDQA right now, but in other versions we've had components where you use statistics to decide if an answer has the right type. And one way to train that is on a bunch of here's a bunch of questions and answers that have the right type. But you could also just train it on here's questions and here's correct answers, and assume for the purposes of noisy ground truth that all the wrong answers have the wrong type. That's not a very good, it's a very noisy ground truth at that point, but it can still be useful.
Thank you.
Thanks.
One more follow-up just on that. The statistical models, are they deep learning neural networks, or they could be any fairly robust statistical machine learning techniques?
Yeah, we generally use best of breed. So for the lat detection, for example, we are using a deep learning neural network. For the answer ranking models at the end, we're using a learning to rank based on JForest and logistic regression and some sort of ensemble. So ranking style models rather than deep learning models. But it's definitely a mix, and we try out a lot of different things.
Thank you. Back to you,
Thanks.
Susan.
Are there others that are?
Svetlana, I've unmuted you. Do you still have a question?
Thank you, Susan. I think the question has been answered.
That's what I thought. Okay. I see Scott has unmuted himself. Do you want to go ahead, Scott?
Yes, thanks, Bill, for your great talk. I'm curious to what degree licensing questions of Wikipedia data might play in the future or even now. So Wikipedia, a wiki site, for example, which is bibliographic data, is CC0 licensed, which is commercial. But other Wikipedia data is other Creative Commons licensed. MIT OpenCourseWare is CC4, sharing for 1, adapting for 2, but 3 non-commercially. Is that an issue, or do you see that being a question on the horizon for you in any way, shape, or form?
Yeah, I definitely think it's an issue on the horizon for us. I mean, right now we don't have this as a product yet, so we're treating everything as this is essentially research, and so anything we can get that's available for research use, we'll use. But if we have a product out there, then obviously we need to be very careful about, like, a product is going to be sharing content with users, and we need to make sure we have the license terms that are going to let us do that. So I think it may be the case that for a lot of applications, the content is not going to be coming from sources like Wikipedia, because the concrete application will be in a specific domain for a particular data set, and oftentimes the content that we'd actually use for a real production application is going to come from the client that's commissioning this application. So if somebody wanted to build like a customer service question answering system for their products, they would use their marketing data as the text that we would be searching over, and the knowledge sources we would be using to pull answers from, and as a result, they own all the copyrights, and it's their product that we're building for them, and so everything works out. But there are other applications where you really want a mix of like domain-specific, customer-specific content, but also general purpose background knowledge. And then these issues become super important, because we want to be able to do the best we can to provide the customers with as much general purpose background knowledge as we can in advance. And then also let them complement that with their own customer application specific data. And then getting the licensing terms worked out is really important. And I think in some cases, content requires like there's plenty of content out there where you can get it as long as you pay some money, and then it becomes just a business decision of, is the value that this content can provide to customers worth the price? But certainly you don't want to take content willy-nilly and just ignore the licensing issues. But I guess I don't have really a super detailed answer about the particular license variants that you're referring to you typed a lot more detail in your Zoom question. So I can't say much more than that, other than yes, it's definitely a big deal.
As a quick follow-up, do you see more and more data sets being useful coming from Wikipedia itself in the future? That, you know, so the actual data sets that you begin to work with, as distinct from what you've described with the IBM data sets here, you know, become significant?
I think Wikipedia's got a really useful sort of high-level model of the whole world, in the sense that like it knows many super important entities like cities and states and places that are important to many different business domains. The fact that Trenton is in New Jersey, it matters to a lot of legal domains, but it matters to medical domains if you want to know, like, this person was in Trenton and they got this disease that's common in New Jersey. Name 50 other domains, you probably, the basic geography knowledge of the world is useful to most of them. So I think it's a really valuable resource that a lot of business applications are going to want to depend on, and so getting the licensing right for that resource is valuable. But it's certainly not the only really valuable resource out there, and I think we have a lot of other licensing terms to deal with on other resources that are out there too.
Thank you.
Thanks.
Jim, I've unmuted you because I think you may have a remark that relates to this conversation.
Oh yeah, hi Susan and Bill. Thanks again for the great presentation. I just want to put in a plug for the conference that I saw you present this at the Advances in Cognitive Systems, and your paper for people who want to find out more. There's a link you provided in the abstract. So I just want, and there's other great talks and presentations there. So thank you, Bill. My question is, I think you mentioned you cannot release the data set for the training of the statistical model. Is that correct?
So for the Factoid 1527 data set, that's correct. For Squad, of course, that's already out there. It comes from Stanford. But the data we use for the Factoid 1527 is confidential. It was built in coordination with a customer, and the customer owns rights to the data.
Okay. Is there any possibility the customer would allow it to be released, or do you think that's not the case?
I don't think so. I've asked in the past and have been told no.
Okay. I just want you to know that Susan and I are always happy to help, you know, on things like that, getting things opened up and the permissions if there's interest and willingness. But I guess in this case there isn't, so we'll just let it pass.
Thanks. Yeah. Well, in the future, we're going to try to focus on, even if it's not data that's already public, it's focus on data that can be made public, because it's really a limitation if you're trying to do research and communicate with the research community if you have data results that you can't share. So we're going to try to avoid that. In this particular case, we did a lot of this work around this particular customer, and we had a lot of results, and we thought they were interesting, and we wanted to get them out there. So that's why that happened.
I totally understand. Thanks, Phil.
Thank you. Other questions?
I've just unmuted Maple. He may have a question.
I was asking a question about non-factoid questions. I think I wrote it, but the question is, the evolution has been going toward non-factoid questions being answerable. And the way I see it, they're becoming more important to users. And so my question is, how do you evolve what you're doing into that?
It's a great question. So I definitely think that the vast majority of questions that get asked are non-factoid questions, and they are super important. And they're a big focus of the Watson Discovery product now. Watson Discovery has sort of two options for getting results back, and neither of them at the moment is factoid. One is get me back entire documents. So I ask a query, and I just want to see documents that are relevant to that query. And the other is passages, where the person calling the API has the control to say how much passage they want. And so you can say, I want 100 words, or I want 1,000 words, or any whatever length you want, and you get back some results. But what it doesn't really do right now, and what would really be a big improvement in the future, would be where Watson figures out on its own what the appropriate length of passage is. That this question really needs 2 sentences to answer, but this other one here needs the entire book to answer. So I'm just going to point you to the book that answers that question. I think that Squad is sort of an interesting step in that direction. We kind of finessed it in this talk, but Squad is a kind of a factoid system, but kind of a maybe a little bit more than factoid system. Like if we look at here's the sample question I showed earlier. It's asking where, which is kind of a place thing, but the answer is a prepositional phrase. Sometimes you'll see a full, like a relative clause or something like that as an answer in Squad. Squad is like mostly factoid and a little bit factoid-ish like this, where it's debatable whether it's factoid or not. But I think the general problem of bigger, longer answers is super important. And I think I still believe that the same trend that we saw earlier, that having a bunch of rules and knowledge bases and models is valuable in that context. But you can also just do a lot with statistical analysis as well. And I think this is a big priority for us. But factoid question answering is still an interesting subset of all the questions that get answered, and it's still nice to be able to do well on that. I think because there's a lot of things like answers have explicit types that are unique to the factoid question answering system, my guess is that a comprehensive system would still have a factoid module, or at least some logic that's specific to factoid questions that provides value only for factoid questions. And it's only providing value for a small percentage of the time, but when it does provide value, it provides a lot of value. So this is so I think that's where it is here. So definitely right that non-factoid is super important, but I think factoid has a role as well. Sorry, go ahead.
We are running late, but Chitra has 2 more questions, so I suggest you just ask them, Chitra.
Well, I see them on the chat now, actually. So I see I think probably the second one. Is this in the IBM Product Map, and is there a timeline I can share? GDQA. So it's not on the product map at the moment. It's a thing we've been working on for a long time, hoping to get it into the product map. I think there's still a real question in the minds of the leaders as to whether the right solution is something like DDQA or something like the single strategy statistical system. I think that's not going to be decided without more evidence. And once there's solid evidence of a technical approach that's really viable, I think it'll be a lot easier to get onto the roadmap and to really get to become a product. But it's not. I don't think. I mean, even if I were in charge, it wouldn't be going live as a product today, because I think it needs more work to really be valuable to customers. The other question you had was about how far along is it in being able to retrain for other narrow domains. I think the technology, the answering technology is well suited to that, but what we don't have is a lot of tooling to help you do that well, and to make it convenient and easy to use. So that's another gap that really needs to be added to really to have a complete product that would be valuable.
Thank you so much, Bill. And please, everyone, thank Bill in the chat if you enjoyed this talk. That was wonderful. I'm sorry we ran over, but people were so interested.
Thanks, everybody.
Thank you. I'll stop recording in a moment.